Alright, this video is to take a look at arithmetic and geometric sequences, which are just two different kinds of patterns, and in math class we call those sequences. So let's take a look at the first one. So for our first sequence that we're going to look at, our first term is going to be -7, and then -3, and 1, 5, and 9, and it would continue if we let it. Now, when we look at a sequence, we're trying to see what happened between one term and the next. So between -7 and -3, we can tell that it changed 4. And since they're negative numbers, we're going up. We're getting closer to the positives. So they added 4 each time in this sequence. Since they added, that means that this is going to be an arithmetic sequence. So an arithmetic sequence is when you add or subtract to get to the next term. So an example of a sequence where maybe they subtracted could have been 10, 7, 4, 1, where they subtracted 3 every time. That's another arithmetic sequence. Now the number that they are adding or subtracting, so the +4 up here and the -3 down here, that's known as the common difference. That's just the number that they are adding or subtracting to change terms in that sequence. Now here's another sequence, and we want to see how it is changing. So the numbers are alternating between negatives and positives, which means we can't be adding because we'd get more positive, and we can't be subtracting because we would only get more negative. So we must be multiplying, and to change between negatives and positives every time, we have to be multiplying by a -3 in this example. So every time they're multiplying by a -3, and since they are multiplying, that makes this a geometric sequence. So in a geometric sequence, you multiply to get to the next term. Now there could be an example of a sequence where it looks like they are dividing to get to the next term. For example, in this sequence, this looks like divided by 2 every time. But instead of writing it divided by 2, we're actually going to write that they're multiplying by 1/2 or by 1/2 to keep with our pattern of geometric sequences multiplying every term. This is going to help us when we write our formula to find the 10th or the 74th or the 100th term in our pattern. Now the -3 that we were multiplying by, the 1/2 we were multiplying by, those numbers are the common ratio, whatever number we had to multiply to get to the next term. So for arithmetic, it's common difference, and for geometric, it's common ratio, also known as our constant multiplier. So going back to our example of an arithmetic sequence, we have our formula over here that helps us find the nth term. And when I say the nth, I just mean whichever number they want us to find. So this n stands for the term we need, the term that we need to find. Both places that n shows up. Now A1 just stands for the first term in the pattern. So that is where we're going to put, in this case, the -7. Now D stands for the common difference that we were talking about, what it is adding or subtracting each time that the pattern continues. So say they asked us to find the 42nd term. We would write A parentheses 42, since that's the term we need, and where the A1 goes, all we have to put is -7, plus, in parentheses, another 42, minus 1, for the term we need, and D, the common difference. We said that before that was +4, so we're going to put a +4 in there. Had it been negative, or had it been subtracting, we would have had to put a negative. So if we use our order of operations to help us solve this, we know that the first thing to do is to do 42 minus 1, and we get 41. The next the next step that we've got to take is multiplying 41 times 4, which will give us 164. And last step, if we add -7 to 164, we get 157. So the 42nd term in that pattern is 157. Now let's look at a geometric sequence and how that formula is just a little bit different. So our geometric sequence from last time started out with -3 and then 9, -27 and then 81. And we've got our new geometric formula. The n is standing for the exact same thing, the term that we need. So that part does not change. There's also an n up in the exponent by the r. The r is the only thing that's different, and that is that common ratio, whatever that we are multiplying by to get from term to term. Again, the a1 is going to stand for the first term in the sequence, just that first number in the pattern. So, if they ask us maybe find the 13th term, then we're going to write A13 equals, and for the first term we don't put the A or the parentheses 1, we just put -3 times, and our common ratio, we had said before that it was multiplying by -3 every time. So we're going to put -3 in parentheses, and up again that n is going to be 13 minus 1. So our order of operations is going to tell us to subtract those exponents first. So we've got -3 to the 12th power, and if we put that in our calculator, we're going to end up with -3 times 531,441, and as our last step, if we multiply that by 3, we're going to end up with -1,594,323. So the 13th number in that pattern is pretty small, -1,000,000 and something. So we need to be familiar with both types of sequences, what they are, when we can tell which it is, and how to use those formulas to find a number later on in the pattern.